we will explain how to perform a simplified life cycle assessment or LCA of a motherboard using openLCA software. What is LCA? Life cycle assessment is like telling the story of a product's environmental footprint. We analyze all stages: material extraction, manufacturing, transportation, usage, and end of life recycling or disposal. Why LCA is important? Electronics like motherboards are complex and resource intensive. LCA helps us identify which stages contribute most to environmental damage so companies can design greener products. What is a simplified LCA? A simplified LCA is a less detailed, faster, and cost effective approach to evaluating a product's environmental impact over its life cycle. What is openLCA? openLCA is a free software that makes LCA easy to calculate. It uses large databases that already have data on the environmental impacts of material and manufacturing process. Now, let us take a look at how we can calculate LCA of motherboard using openLCA. Let us take a look at how we can perform LCA of motherboard using openLCA. For that, we will first need to download the openLCA software in our computer. Uh, we can download openLCA from this website by clicking on this button. After the openLCA software is downloaded, we can install it. After downloading, we will also need a database for the for performing the LCA of motherboard. So the database that we uh, for the database we can use this website, that is openLCA Nexus. From here we will download the ELCT database. You can download any database that you want, but for this video we are using the ELCT database. Now, after you are done downloading the ELCT database and the openLCA software, we can open the openLCA. After opening, we need to import the database that we just downloaded, that is ELCD, this one. After that, we will create a new database from scratch. Database name, we can uh, name the database as Mobo. You can select the folder if you want. We will create an empty database. I have already created, so I am not creating it again. For the Mobo database, right click and then import file in the database that we downloaded from the LCA Nexus. We will import that database into this new database that we just created. After that, all the contents of the ELCA database will be seen in the Movo database as well. After that, we will need to create the processes. We will create the processes. How do we create a process? New process. We click on process, then new process. In new process, we enter the name of the process. Select create a new flow for the process. Then name of the new flow and reference flow property that you want. We will create 5 processes: capacitor, connectors, IC, PCB, and solder. Then after creating them, we will add the inputs and output for the processes. In input, we will need to add the flows, the provider, and the amount. And the output we will need to add the amount. So similarly, we will do this for all other processes like capacitor, connect, connectors, IC, and solder. After we are done creating all these five processes, we'll create one more process and name it motherboard assembly. In this motherboard assembly process, we will go to input outputs. In input outputs, for inputs, we will drag and drop this processes in the inputs, all the five processes that are capacitors, connectors, IC, PCB, and solder. After that, we will enter the amounts of these processes for this processor and the amount for the motherboard process for the output. Then after we are done, we will create a new product system. We will name it, for example, M M A. We will select the motherboard assembly process that we just created. For process type, we will select unit process. Then we will click on finish. Check in the model graph if it has all the processes that we added in the motherboard assembly. It should have all the processes that we added in the motherboard assembly, or else something went wrong. We need to go back and check. After that, if there are all the processes that we added in the motherboard assembly, we can click on calculate and we can select the impact assessment method here. This graph shows the major contributors. This is the inventory results, impact analysis, process results. Uh, the input show the consumed materials and the output shows all the emissions that are made by the PCB components, by the motherboard components. This is the contribution tree. It shows the contribution of the components of the motherboard. This is Sankey diagram. This visualizes how electricity and copper flow into PCB, which dominates the overall impact. Thank you.